In this vlog, we are solving various forms of equations. Some of them we apply factoring properties. That's if you have the same variable, but it's to two different powers. Then on some of them, we are applying linear properties where you isolate the x by itself and get rid of the operations on the side of the x. So in this first problem, we have x to the second power minus 11x plus 24 equals 0. So what I do is I make a solution box for where I'm going to put my answers. And I got to identify what the structure is to the variable in the equation. So we have x to the power of 2. And then we have x without a power, meaning it's to the power of 1. So same variable, different powers, and that is when you have to apply your factoring properties. So in factoring properties, first you want to see how many answers you have, which this one would have 2. Then you want to make sure the equation is equal to 0, which this one is. And then I need to count how many terms I'm going to try to factor. It's either 2, 3, or 4. And this one appears that we have 3. So that would be a trinomial. So I would first check to see if I have a GCF. Then I would set up my factor table to try to find two factors that add to the middle. So first things first, the GCF. There's no x on the end. There's no negative in front. Then 1, 11, 24 is just in 1's row, so we would not carry that out. So A, B, C. So 1 times 24, and that's going to be 24. It's positive 24. So I got two factors that need to make to multiply to positive 24, so the signs on those factors have to match. Just put negative, negative. They have to add to negative 11, so I think they will both stay negative, negative. So now I start finding factors of 24. So 24 divided by 1 is 24. That adds to negative 25. That's 2y. 24 divided by 2 is 12. And that's negative 14, so no. 24 divided by 3 is 8, and there's your negative 11. That's what the factors are. Okay. So now I'm going to rewrite this trinomial into a product of two binomials. Okay. So I put in the mystery numbers negative 3, negative 8. The a is 1x to the second power, so we know that x to the second is x times x. And I will be placing the coefficient of 1 in front of each of my x's. Now these are already in simplest form. 1 and 3 you can only divide by 1, and 1 and 8 would only be divided by 1. So it's going to be 1x minus 3, 1x minus 8. Okay, and that's the two binomials. So we write 1x minus 3 times 1x minus 8 equals 0. So this is F1 and this is F2. So 1x minus, now we use the zero product property where we set each of our two factors equal to 0. 1x minus 3 equals 0. 1x minus 8 is equal to 0. Okay, so you don't need the multiplication of 1. X minus 3 equals 0, so plus 3, and you get 3. So there's your first answer. On the other one, you got multiplication by 1. You add 8 to each side, and x is equal to 8. 3 and 8. Okay, my next problem, we have x to the power of 3 plus 5x to the power of 2 minus 9x minus 45 equals 0. So I'm solving for x. The x variable is to the power of 3. It's to the power of 2, and it's to the power of 1. So same variable, different powers, 3 different ones actually. So we are going to apply, once again, our factoring properties to try to solve the equation. Okay, so x to the power of 3, that means there would be 3 answers to that. And you are equal to 0. Now you count how many terms you will be factoring. This one would have 4. Okay, so 4 terms is factored by grouping, and then at the end you see if you have difference of perfect squares. So you set up the grouping organizer. So parentheses plus parentheses, and the same thing with the GCF lines outside. And then we're going to have a little parentheses and a big parentheses. Now remember, you got to check that parentheses to see if it's then can be broken down as a difference of perfect squares. Okay, it's right there too. Okay, so I grouped the 1x to the third plus the 5x to the second, and then I grouped the negative 9x with the minus 45. Okay, so in the GCF, now both of these terms have x, so I take the x from the end, the second power x, and then no negative. 1 and 5 are only divisible by 1. Then here we're not going to be factoring out an x because 45 is a constant. It doesn't have x at the end there. There's a negative in front. And then the 9 and the 45 are divisible by 9. Okay. Okay, so then I go up here and divide by 1x to the second. And I go here and divide by negative 9. So 1 divided by 1 is 1. X third divided by x to the second leaves us with a remainder of x. Then 5 divided by 1 is 5. X second divided by x second leaves me with no remainder. So 1x plus 5. Now negative 9 divided by negative 9 is 1 with x. And then negative 45 divided by negative 9 is positive 5. So the expressions in the parentheses match both as 1x plus 5. So we factor out 1x plus 5, and then I cross that out. Then I put my 1x to the second power with my negative 9. So you can write it as minus or plus negative. It doesn't really matter. Now take these 1s off the front of the x. I would do that. So I would put over my x plus 5 because x and 1x are the same thing. Then x to the second minus 9. Well, this is a positive and a negative, so difference. It's definitely a difference. And then are these perfect squares? Well, x to the second is because that's x times x. You go down here, 9 is a perfect square because that's 3 times 3. So both of those terms are perfect squares and positive, negative. Or you need this to be a minus or a negative. So x, 3, 3. So you're not going to put this alongside the x plus 5. You're going to replace this with x plus 3 times x minus 3. Okay. So f1, f2, f3. So x plus 5 could equal 0. X plus 3 could equal 0. X minus 3 could equal 0. So we're going to subtract 5 from both sides, and we get negative 5 for the first answer. Then we subtract 3 from both sides, and we get negative 3 for the second. Then the last one, we add 3 to both sides, and we get 3 for the third. So negative 5, negative 3, and 3. Okay, next problem. We have x to the second power plus 6 equals 127. Now, we have x to the power of 2, and there isn't x to any other power, so this is an x second only. So this would not be factoring properties. This would be linear properties. Okay, so there are 2 answers. Put how many answers? Now you collect the x terms if you have more than one, but we only have one single x term, and now you solve, okay, by getting the x by itself. So we don't have a multiplication, we have a second power and a plus 6. So we have to take out the plus 6 by minus 6 first. Then to undo the second power, we find the square root of what we have after we subtract 6. So we subtract 6, that's 121. Then I find the square root of 121 because that's how you get rid of a second power. Now remember, a square root could be the positive or the negative. Now I could look at my chart to find this because here's 121. That's 11 times 11. Okay, so the square root of 121 is 11. So it could be 11 or negative 11. Okay, next problem. Negative 4x to the second power plus 10x equals 0. So in this one we have x to the second power with x to the first power, so same variable, different powers. That has to be factoring properties. So you have two answers. Okay, zero's there. You have two terms, so it's a binomial. So binomial is GCF, then you see if the remainder is a difference of perfect squares. That's after you do the GCF. Okay, so x on the end, you bet. Negative in front, yes. Now 4 and 2 wouldn't be 4, or 4 and 10, excuse me. 10's not divisible by 4, but they both would be divisible by 2. Okay, so negative 2x is what we're going to divide by. So we go up here and divide by negative 2x. So this is positive 2, then we divide the x second by the x, and we get a remainder of x. 10 divided by negative 2 is negative 5, and x divided by x is a cancellation. So we bring that negative 2x GCF down here. Now, see if that's a difference of perfect squares. Well, you have a positive and a negative, so the difference is there. But 2, right away we're in trouble because 2 is not a perfect square. So you write no, and you just put that factor of 2x minus 5 after your GCF. Okay, so F1, F2, now you apply the zero product property of your factors. Negative 2x equals 0, 2x minus 5 equals 0. So I got times negative 2, so I'll just divide by negative 2, and that's 0. Here I will add the 5, so 2 times x equals 5. Then you divide by 2, and you get 2.5. 0 and 2.5. Okay, next problem. 10x to the second power minus 19x plus 7 equals 0. So we have x second and x in this problem here and here. So that's again factoring properties. So there would be two answers. The zero's there. Now which factory property am I using? I'm using the trinomial because there's 3. So GCF and the t-table. I don't see x, I don't see the negative, 10, 19, and 7. I think those are only in row 1. So 1 means we don't do the GCF. So 10 times 7 is going to be 70, positive 70. Okay, so the factors have to be a match to multiply to a positive, so we'll put in double negative. You could also start with double positive too, but this one's got to be double negative because it's got to add to negative 19. So 70 divided by 1 is 70. Add those, you get negative 71. You're too wide, too high. 70 divided by 2 is 35. That's negative 37, too high. 70 divided by 3 is a decimal. 70 divided by 4 is a decimal. 70 divided by 5 is 14. Okay. So we add those and we get negative 19. Now, your a now is 10x to the second power. So at the end, the numbers in front of the x's, the coefficients in front of the x's need to be 2 factors of 10. So negative 5, negative 14. Then we're still going x, but we're putting 10s now in front of the x's. Okay. Now we don't leave it like this. We need to simplify the binomial. So 10 and 5 are 5. So you divide by 5 here, then 10 and 14 are both in the second row, so we would divide those by 2. So now we get down to 2x minus 1 and then 5x minus 7. So we can check whether we did this right by timesing the numbers in front of the x's. 2 times 5 is 10, and bingo. After the x is -1 times -7 is positive 7, bingo. So we have 2x minus 1 times 5x minus 7 equals 0. So factor 1, factor 2. So we got times 2. We're going to add 1 to both sides, and that's going to be 1. So you can put 0.5 or you can leave it as 1/2. I don't really care. And over here, we need to add 7 and divide by 5. So 5 times x equals 7, then divide by 5. And that's going to be 1.4 or 1 2/5. Or 7/5. Okay, next problem. -3x to the third power minus 30x to the second power minus 27x equals 0. So right here we have x to the third, x to the second, and x to the first. So obviously we're applying our factoring properties to solve this. So we got x thirds, so that would be 3 answers. And the zero's there. So you have a trinomial, so like this one, we set that up with the GCF and the t-table. So we have an x on the end, we have a negative in the front, then 3, 30, and 27. Here's 3, here's 30, here's 27. Those are all in the third row, so we factor out the expression -3x from each of the 3 terms. So that's going to be 1. Now x third divided by x. That leaves me with the remainder of 2 x's. Then -30 divided by -3 is positive 10. Then x second divided by x leaves me with x. And then -27 divided by -3 is positive 9. And then x divided by x is a wipeout. Okay, so you put your GCF -3x down there. Then ABC. Okay. So 1 times 9 is 9 because that's your new ABC. So that's a match. So let's put double negative. They have to add to positive 10. So 9 divided by 1 is 9. Add those, you're at -10. So that's the right pair. You just have to make it positive 10 by making the signs double positive instead of double negative because they still match. They just match as double positive. Now, put in your positive 1, positive 9. Now you got to look here. This 3x is out. A is now 1x to the second. So that's x times x, and then 1, 1. Okay, so 1 and 1, you would only be able to divide by 1, and same with the 1 and the 9. So 1x plus 1, 1x plus 9. Okay, so after this, we're going to put 1x plus 1 and 1x plus 9. Okay, so F1, F2, F3, and I get my 3 answers. So -3x could equal 0, 1x plus 1 could equal 0, 1x plus 9 could equal 0. Okay, so we'll divide by -3 here, and x would equal 0. Get rid of your times 1, you're going to subtract 1 from both sides, and x equals -1. You're going to minus 9 from both sides, and x equals -9. So there's your 3 solutions. Okay, we have x to the second power plus 6x minus 10 equals 0. So we have x to the second with x. So again, we got to use the factoring properties to solve it. So there would be 2 answers. And the 0's there, so the factoring property I want to use is the trinomial, which is GCF, and the table. X, no, 1, 6, and 10's 1, so get that out of there. So 1 times negative 10 is negative 10, so that's a mismatch. Positive, negative, it's got to add to positive 6. Okay. 10 divided by 1 is 10, that's negative 9, that's too wide. 10 divided by 2 is 5, that's negative 3, so you're too narrow now. You'll never make the sum 6 because now your sum's negative 3. That's too narrow of a sum to ever be 6. So we go quadratic formula. There's a quadratic formula. Again, if the sum is too narrow or you start greater than 100, use a quadratic formula. So x equals opposite of b plus or minus the square root b squared minus 4ac, b squared minus 4ac over 2a over 2a. Okay, so the opposite of b is negative 6. B to the second, you got 6 to the second, and then 4a is 1, and c is negative 10, and downstairs we got 1. So you got a negative 6 in front of your plus and minus. Now you got 2 times 1 is 2 on the bottom. Now you got to figure out what your square root is. So here's what I have in the square root. 6 to the second minus 4 times 1 times negative 10. Okay. Actually, I'm going to do this the long way. I'm going to put my minus right there. That's outside, right in the middle. And then 6 to the second. Well, that's 6 times 6. Then after the minus, you have 4 times 1 times negative 10. So this is 36. That's before the minus, because that's where 6 to the second was at. Then 4 times 1 times negative 10 is negative 40. Okay. So you have minus and then negative 40, so that would go to plus plus. So now that's the square root of 76. Okay. So now we're going to find the square root of 76, and that gives me 8.72. So positive or negative 8.72. Now you find your two solutions. So negative 6 plus 8.72 equals, then divide by 2. 1.36 is my first solution. Negative 6 minus 8.72, click equals, then divide by 2. Negative 7.36 is my second solution. Okay, and then the last one in the vlog. 4x plus 2 equals 3x minus 6. Well, you have x and then x. So they are not to two different powers. They are x only. Okay? So this is linear properties. There would be one answer. Okay? Collect the x terms if you have more than one. Obviously, you can't solve and get x by itself when there's more than one. So, opposite sides, take out the smaller one. 4x minus 3x is 1x plus 2 equals negative 6. Now you solve. You got times 1, which means if you have times 1, you don't have times at all. You just have plus 2. So you're just going to minus 2 from each side. And then negative, you don't have to square root here because x, we don't have the second power operation. That's negative 8.